Okay, so number 3, it says that a new limited edition car gains 1/3 of its value every year. Which graph could represent the relationship between the year and the car's value? So what we should be doing regularly is annotating our word problems. Pick apart what information within the word problem we can actually pull from that to use when we're evaluating what our answer is going to be. So the important information within this problem would be the fact that the car is gaining value, gaining 1/3 of its value specifically. So if we know that the value of the car is going up over time, the graph has to be showing an increase as well. So we want to make sure we use the process of elimination just so that we can, minimize the number of answer choices we're actually working with. So by looking at these 4 graphs, we know that both A and C are showing a decrease. The graph is going down. And if you add an arrow to both, you'll see that it is going down. So neither A or C would work. Now, both B and D are showing that there is growth taking place, but we're looking for exponential growth. So D would have to be the correct answer. B is showing what we would call linear growth. In that root word of line, we have a straight line here. In this unit, we are focused on exponential growth, which means it's an increasingly high growth over a period of time. Not linear, meaning it's growing at the same exact rate every single time throughout the sequence. So it has to be B. All right, number 4. A new online music service has a collection of 1,726 songs. It expects to quadruple the number of songs each year for the next few years. So again, let's go ahead and annotate and pick apart what information we're going to use to solve our problem. So the first piece of valuable information within this is the fact that we are starting with 1,726 songs. And we also know that the number of songs is quadrupling. And we know that that means it's being multiplied by 4. Quadruplets is 4 kids. So 4. And then we have our starting value. So we know that this is going to go in place of A, because that is our initial value. Again, we have our function. And then we know that we're multiplying by 4. And if you remember what we said in the previous video, if we are multiplying by anything, or whatever we're multiplying by, or the multiplier is going to go in place of B. So we know that 4 is our B. Now the second part says for us to write an equation representing the relationship where T is time in years and S is the number of songs available. So let's remember that this exponent here is going to represent time, or just the frequency of how something is happening, or how often something is happening. So if this says that T represents time in years, we know our exponent is going to be T, but we also have this S here. So we need to figure out where we're going to put that S. We already have our value for A, we have our value for B, and we have our value for our exponent. So what we're left with is this. We know that we're trying to calculate the number of songs, so our final answer will be blank number of songs. So if S represents the number of songs, then our final answer has to be S equals something. We don't know how many years we're calculating just yet. It's just asking us to create an equation. So we can go ahead and use those quantities that we've already pulled apart from the problem to create our equation. So our A value is that 1,726. Our multiplier is 4, and our exponent is T. That is your final answer. Now for number 5, it says that Jada saw a music video that her favorite artist recently posted online. The equation V of T equals 416 times 3 to the power of T, which represents the number of views, V, of the video, T days since Jada saw the video. So again, let's go ahead and annotate. We know that 416 is going to be our A value. It's in the place of A, so that's our starting amount. 3 is our multiplier, or our growth factor, or common factor. Our exponent is T, which represents the days since she saw the video. And V represents the number of views of the video. So letter A is asking us to find V of -3. If you look at the initial equation, we have V of t here. And then we have here that says V of -3. So this is simply telling you that t is -3. So when you're calculating this, you are simply doing 416 times 3 to the power of -3. And when you calculate that, your final answer should be 15.4. That is all you're doing for letter A. Now letter B is asking you to explain what these different values mean. And I want you to make sure you're explaining them in context. So V of -3, since it's a negative and we're talking about days since she saw the video, if it's -3, that -3 would represent 3 days before she saw the video. We're going back in time. So in connection to letter A, this value in context means 3 days before she saw the video, it had 15.4 views. And then also this 416, the second part of letter B, is asking for you to tell me what 416 represents from the initial equation. And that 416 would represent the number of views the video had when she first saw the video. I don't have any space to write that out, but you can go ahead and rewind and listen to me explain it again. For number 6, it's simply asking you to complete the table based off of the equation that's given to you. The equation is y equals 8 times 2 raised to the power of x. The table provides you with 7 different values of x. All you are doing is plugging those values into the equation and solving for y. So the first one, for example, you would put 8 times 2 raised to the power of -3. And remember, in your calculator, in order to put an exponent that is anything other than 2, you have to use this symbol, which is located directly above the division sign. So the first value would be, again, 8 times 2 raised to the -3. It would give you 1. And just complete the table, and you will end up with a completed table that has about 7 different points that you would eventually be able to plot on a graph, and it would show you either exponential growth or decay. And the last problem, we are talking about medicine in a person's body and how that dosage or the amount of medicine in the bloodstream either decreases over time or increases. Typically, it's going to be decreasing. So the question says the milligrams of medicine in a person's body is given by the equation A equals 650 times 3.5 over 4 raised to the power of t, where t is the number of hours since the patient took the medicine. How much aspirin, or just any medicine, will be left in the patient's body after 2 hours? Round to the nearest whole number. So we were provided with the equation initially here, and now letter A is telling us t. It's telling us to calculate the amount of medicine after 2 hours. So in your calculator, you would do 650 times parentheses 3.5 divided by 4, and your exponent would be raised to the power of 2. And your final answer should be, let me go ahead and calculate this again. It should have been 497.65. And I asked that you round it to the nearest whole number, so you should have ended with 498 milligrams. All right, letter B is asking for you to tell me, what does 650 tell us about the situation? 650 is in the place of A, which is our starting value. So this 650 means that when the person first took the pill had 650 milligrams of medicine. Or there was 650 milligrams of medicine in the person's body when they first took the pill. And then it's asking you to explain, what does this 3.5 divided by 4 tell us about the situation? that is going to be our growth factor. That is in the location of B within our equation. So it's simply our growth factor. That is how much of the medicine is being lost as time progresses. All right, if you have any questions on any of those, feel free to send me a DM on Instagram. I am available as needed. Thank you. See you tomorrow.